Hey everybody, this is Mr. Lowry, and today we're working on this assignment, special right triangles. Special right triangles is an idea we talked about in class. There's actually two. Special right triangles refer to very commonly used triangles. Triangles that are used a lot in art, engineering, design, architecture, things like that. And because they're so common, we learn their side ratios, or their basically the proportions of their sides. So, a couple pieces of information you need. This is what you're going to need for the first page. So, this is in your textbook on page 357. It's this theorem, theorem 7.6. Okay, it says in a 45, 45, 90 triangle, the length of the hypotenuse is the square root of 2 times the length of the leg. And they have this little image. So, notice that we have a right triangle. It's an isosceles right triangle. And these are both labeled N. So the two legs of the triangle, it says the word leg, right? Leg means the two sides that form the right angle. So that's these two guys. Okay? The hypotenuse is the other side. It's the side that's across from the right angle. So let me zoom in a little bit here. This is kind of small. Geez, sorry. Camera's not wanting to work with me. All right, so if this is like, let's say n, some number n, then this is just that number times the square root of 2. So if this is 10, this is 10, this is 10 times the square root of 2. This is 5, this is 5, this is 5 times the square root of 2. The square root of 2 is just a number. It's an irrational number, and it's equal to about 1.41. So the hypotenuse of a triangle is always about 1.41 times the length of the leg in a 45, 45, 90. Okay, so this is a key piece of information. If we want to go from a leg to the hypotenuse, we multiply by root 2. If we want to go from the hypotenuse back to the leg, then we need to divide by square root of 2. So page 1 here, zoom out again, is all 45, 45, 90 triangles. What we're going to do is we're going to solve for the missing sides. Okay? We're going to do a few of these together. I'm going to work on some evens with you, and you're going to do the rest of them. Okay? Odds you have the answers in the back, so you can use those to check. Okay? So notice right here, number 2, what I have is this measurement. Okay? This is the hypotenuse. According to that theorem, this guy is square root of 2 times bigger than this guy. So if I want to get from the hypotenuse to a leg in a 45, 45, 90, I just need to divide by the square root of 2. So I'm going to take 20 square root of 2, and I'm going to divide by square root of 2. These are going to cancel, and I'm going to get 20. So x is equal to 20. Okay? X and y are the same measurement. Sorry, oh, I blocked all that out. Let me go back. 2 zoomed in here. Sorry about that. I took 20 root 2 and divided it by root 2. So 20 root 2 divided by root 2, square root of 2. These cancel out and I get 20. Okay? So x and y are the same measurement because they are, this is an isosceles triangle. All the 45, 45, 90s have to be isosceles. So they're at the same measurement. The legs are always going to be the same. The hypotenuse is root 2 times longer than that. Okay, now in this one, number 4, you might be tempted to divide by root 2 because there's a root 2 here. But remember here, this is the leg. This is not the hypotenuse. Okay, so according to the theorem we just read, the hypotenuse is always square root of 2 times longer than the leg. So if I want to go from the leg of a triangle and find the hypotenuse, I'm going to multiply by root 2. So in the first one, we divided by root 2 because we were going from hypotenuse to leg. Here we're going from leg to hypotenuse, so we're multiplying. So we're going to take 6 root 2, and we're going to multiply it by root 2. Okay, now this 6 is also multiplying the root 2, so this is really 6 times square root of 2 times square root of 2. We can really group it any way we want. In this case, I'm going to look at this, square root of 2 times square root of 2. Now there's a few different ways to think about this. You can say that this is 6 times the square root of 4, since 2 times 2 is 4. Or you can think of it as 6 times the square root of 2 squared. Let me zoom in a little bit there, sorry. Write this bigger for you. Okay, so I have the square root of 2 squared, which is also 4. But the idea here is this power of 2 and this root 2 undo each other. So I got 6 times 2 here, because the square root of 4 is 2.